Okay, here are all of the class scores. So you need to have those entered into your calculator, which I have right here. Now, it usually helps out if you sort. Okay, there you go. You can see them. So how do we sort the lists? Well, you push stat, and then you go down to sort A. That's ascending from small to large. And we want to sort L1, which is second, and then the number 2. Or, sorry, the number 1. Sort L1. Do that. And then sort L2. And now when I go back into my stat to edit, they're all in order. Why is it a good idea to sort this? How does that help? Well, it allows us to know what to choose for our window. So the males go from 59 inches and the women from 53 all the way down to 77 and 74. So I'm going to go into window. My X minimum, I'll do 58 inches. X maximum, I'm going to do 76 inches. Count by ones. My Y minimum, 59 inches up to, say, 74. Okay. We'll get to that in a second. Now, I need to find my averages and my SDs. So I push stat, and I go to calc, one variable, and this calculator actually asks for what list you want, so I'm going to do L2. If your calculator just says one variable stat and not all this other stuff, then just put L1 right after that, or L2, whichever one you want to do. So L1, so your calculator might just look like this. One variable stat, and then just put L1 right next to it. Okay. So I get my average is 70.6, and my SD is 3.7. So for the men, my X bar is 73.6, and my SDX is 3.7 inches. I do the same thing with L2. So stat, calc, one variable stat, L2. And this says X's, but they're actually Y's. So my Y bar is 64.6, and my standard deviation is 3.9. Okay, so Y bar is 64.6. Oops. Phone. And my SDY is 3.9. So, which set of heights are further spread apart? The women actually have a higher SD, which that surprises me a little bit. Okay, the average for the men is quite a bit higher, 9 inches higher than it is for women, but the SDs are pretty close, with women being just a little bit above. Okay, so now that we have those, go into your Y equals and turn your plot 1 on. So go to plot 1 and hit enter. And we already changed our windows. So if I push graph, I should see the scatter plot. So maybe I want to change my Y max or my X maximum a little bit. Let's do 80. And then My Y minimum, maybe I want to do like 55 because I couldn't quite see everything. There we go. Oh, there's a point down there that's pretty messed up. So, would you say this has a positive correlation or a negative correlation? Positive. Would you say it's strong or weak? Strong. This is extremely strong. Um, we guessed in our assignment yesterday that it would be positive 0.3. This looks a lot more like positive 0.8. So go ahead and put a guess down. What do you think the R value is going to be? Is that point down at the bottom not supposed to be there? Was there a woman shorter than 50? Was there a woman around 55? What was the shortest woman? 53? Okay, so I'm going to go down to 52. Oh, there are a couple down there. Wow. Okay. All right. So put a guess for the R value. How do we find the actual R value? You go stat, calc, and we go down to linear regression. And I get my R value. Oh, yeah, that's not going to work. Good catch. Linear regression. So my X list has to be L1, and my Y list has to be L2. And I get an R value of 0.96. So, can men's height be used to predict spouse's height? Yeah. Yeah, they are very highly correlated. So maybe we got that one yesterday wrong. Okay. So the next question is, what is the point of averages? What is the point of averages? Well, it's going to be the X bar, comma, Y bar. So it's going to be right there, 73.6 and 64.6. Okay. What is the slope of the SD line? How do I find the slope of the SD line? Well, I draw my football, and in this case, it's like a frisbee. And the SD line actually runs right down the middle of that football. And the slope of the SD line is simply, so slope is equal to SDY divided by SDX. So it's going to be wrong one. It's going to be 3.9 divided by 3.7. So what is 3.9 divided by 3.7? 1.05. Okay, what does that slope mean? Well, it's a ratio that is women's height divided by men's height. So as the women in a relationship get an inch taller, the men are 1.05 inches taller, the men get an inch taller. So it's pretty highly correlated. That actually surprised me. I didn't think it would be that close, it would be that thin, but it is. Okay. So the rest of the paper is basically the same thing, but we're going to use a different data set. We're going to use heights and wingspans.